Hello, welcome back to Slope-Intercept Equations of a Line, Part 2. And now that we have all the preliminaries out of the way in the last section and how it all works, it's very easy now for us to crank through a few problems and just graph equations of lines when they're in slope-intercept form. So these problems will be the same as the other ones, but we'll probably have a few fractions thrown in there because that can make things a little confusing. But for example, the first one, what if we have an equation of a line that's y is equal to 1/2 x minus 2? Now, you know it's not in standard form. You can read immediately that it's in slope-intercept form because it's y is equal to mx plus b, but in this case, the b is actually negative. So the first thing to do is just to write down everything you know. The slope-intercept, or I should say the y-intercept, b is equal to -2, which means that there is a point on this line which is 0 for x and -2 for y. That's what a y-intercept is. And then the second piece of information you read from this is that the slope is equal to 1/2, which, as you all know, is rise over run, so it goes up 1 unit for every 2 units that it goes to the right. Now that you have this information, then it's very simple to graph this equation of a line. We know the line's going to cross at the y value of -2, 0, -2, which means it's going to cross down here. And then we know that the slope is 1/2, rise over run. That means up 1 over 2. So it's a positive slope, which means we rise up 1, we move over 2 units to the right. And so then all you do is connect the dots, and there we go. We're going to try to do it neatly because I'm going to have a few more lines drawn on here for comparison purposes. So for this one, we'll go right through these 2 points. Something like this. So here's our line, which is 1/2 x minus 2. So notice again that you can read a lot immediately off. When you see a mx plus b where you have a minus here, you know that this line is going to be crossing down below the origin somewhere because the y-intercept's negative, which means it has to be crossing somewhere when y is negative. If it's mx plus b where b is a positive number, like +3 or something, then you know that the line has to be crossing here. And then the slope, if it's positive slope, you know that the line's going to be going like this. But if it were a negative slope, you know the line is going the other way. So without even drawing anything, you can see more or less how the graph is going to look before you even do anything. That's actually why we use this form of the equation of a line so much. So the next thing we're going to do is we're just going to bounce around to a few other equations. The next one we're going to have is y is equal to -2/3 x minus 1. So before we do anything, just think, what will this look like? Well, it's going to cross somewhere below the origin, and then it has a negative slope, which means it's not going to go this way. It has to be tilted the other way. So you can imagine it shifted down below the origin and going this way, more or less is how this line is going to